guys, welcome to today's class. Now, in this class, we are discussing some more, few more problems based on half-range Fourier series. Half-range Fourier series means you know that either maybe sine or cosine series. Now, today I'm going to discuss a few more problems based on your VTU your model paper and also uh, last year question paper. Find the half-range Fourier sine series. One of the problem is already written on the board. Find the half-range sine series of f of x is equal to sine hyperbolic ax divided by sine hyperbolic a pi in the interval 0 comma pi. Observe carefully here, sine hyperbolic ax is a function, is a function of x, but sine hyperbolic a pi is a constant value. Now carefully I have to observe the function and carefully I have to find out half-range Fourier sine series. Now first for our convenient, first we are going to write what is my given. Given is nothing but f of x is equal to sine hyperbolic of ax divided by sine hyperbolic of a pi. Okay, over what's the interval 0 comma pi. I told in my previous videos for half-range Fourier series, when you're talking about half-range, what is my general interval is 0 to L, equal to the given interval. What's the given interval? 0 comma pi. That implies what is my L value? L is equal to pi. That implies what is my n pi x by L? N pi x by L is nothing but nx. Okay. In the next step, based on that, we are going to construct half-range sine series for the given function. Okay. Now, half-range sine series for f of x over 0 comma pi is f of x equals summation in ranging from 1 to infinity bn sin nx, where what is my bn formula? 2 by L is 2 by pi, 0 to pi f of x sin nx with respect to x. Okay. In the next step, I want to find out the value of f of x into sin nx, because here they are expecting sine half-range sine series or Fourier sine series. 2 by pi, 0 to pi. Okay. The function is sine hyperbolic of ax divided by sine hyperbolic of a pi is a function they given in f of x, and then sin nx with respect to x. For my convenient, I am going to keep this function outside. Which function? Hyperbolic a pi is a constant. In the next step, 2 by pi of sine hyperbolic a pi, 0 to pi. Yeah, you already know that hyperbolic function can also be written as in terms of exponential. Why I am going to express a hyperbolic in terms of exponential? You know the formula, what is integration of e power of x into sine of bx plus or minus c. Therefore, then easy to apply the formula. You already derived that result where in the last year in the reduction formula. Therefore, and also you not last year you already derived that result in second view. Now that is now is easy to proceed. Therefore, what I'm going to do? First, I'm going to express hyperbolic function in terms of exponential. Sin hyperbolic x is nothing but e power of x minus e power of minus x divided by 2. Now from this, okay, e power of x minus e power, what is now from this, yeah, here actually. Now first from this, first I am going to write what is my sine hyperbolic ax. It's nothing but e power of ax minus of e power of minus ax by 2. Okay. In the next step, e power of ax minus of e power of minus ax divided by 2 into sine nx with respect to x. In the next step, 2 to denominator 2 and outside numerator 2 are cancelled. Therefore, first we are going to cancel for these two. Okay. And then what we are going to do in the next step, first you multiply by sin nx with e power of ax and v power of minus ax. And then you take from the linear property of integration, take integration of first term and integration of the second term. In the next step, 1 by pi into sin hyperbolic of a pi of 0 to pi e power of ax sin nx minus 0 to pi e power of minus ax into sin nx with respect to x or dx. Okay. Now each term is in the form of integration of e power of ax into sin of bx plus or minus c with respect to x is nothing but e power of ax divided by a square plus b square quotient of exponential and trigonometric function of a into sin of bx plus or minus c minus b into what actually cos of bx plus or minus c. Now this thing you already known that this formula we already derived, where you already derived in where in view 11. Now this is both the function is in the form of e power of x into sin of bx plus or minus c. In the first term, first integral, my a is a and then b is n. In the second term, a is minus a and b is what? N only. Okay. From this formula, yeah, 1 by pi into sin hyperbolic of a pi of e power of as divided by a square plus b. B means what? Quotient of x in trigonometric function. N square. Okay. Of what's the thing? A into sin nx minus n into b. B means n into cos nx. Yes. Now better I to keep this separately 0 to 5. The next is similarly we go for the second term for the same formula minus e power of minus ax divided by a square minus a whole square. What is minus a whole square? A square only. Plus n square of what's the function? The function is nothing but a minus a sin nx minus n into cos nx. What's the limit? 0 to 5. Okay, 0 to 5. Now, I think it's clear, it's all written on the board which formula we are going to using here for view formula. In the next step, before moving to the next step, I told number of times, whenever having a product of sin or cos, first you verify that what happened, that function value corresponding the limit. Now here, first you have to take for sin nx. Sin nx for x is equal to pi is sin n pi. What is sin n pi is 0. Put x is equal to 0, sin 0 is 0. Similarly, cos nx for x is equal to pi, cos n pi. What is cos n pi value? Minus 1 to the power of n. X is equal to 0. What is cos 0 is 1. Okay. In the next step, 1 by pi into sin hyperbolic a pi of. Now, observe carefully. For sin nx, for upper and lower limit is 0. Where you have sin, better I to write that is 0, not necessary to apply the limit for this function. Which function? A into sine nx. These two terms are must be 0. It's already verified. If only we are applying the limit though inside the proper bracket, those terms having cosine function. Okay. Now, keep the constant. What's the constant? A square plus n square is a constant. Apply the upper limit. What is my upper limit? Pi. E power of a pi half. Yeah, this is 0 minus n into what is the value of x is pi cos n pi. What is cos n pi? Is minus 1 to the power of n. Okay. Minus lower limit. What's the lower limit? E power of 0. What is e power of 0 is 1. 1 into this is 0 minus n into what is cos 0. What is cos 0 is 1. Close the flower bracket. This is nothing but upper and lower limit of the first integral, and move to the second one. Minus 1 by a square plus n square of, apply the upper limit. What's upper limit? E power of minus a pi of minus n into cos n pi is minus 1 to the power of n, minus e power of 0 is 1. This minus n into cos 0 is 1. Okay. Yeah. Now move to the next step. While move to the next step, observe carefully. Now I have to, what's a common factor? A square plus n square. Therefore, 1 by pi into a square plus n square into sine of hyperbolic a pi of, what's the remaining here? Now I have to multiply that. What we get? Minus n into minus 1 to the power of n e power of a pi. Okay. This is minus into minus plus n. Okay. And then minus into minus is plus n into minus 1 to the power of n into what actually? E power of minus a pi. What is this actually? Minus into minus plus, plus into minus is minus. Observe carefully. Minus into minus plus into minus is minus n. Minus into minus plus into minus is minus. We get n. Now what are the terms are cancelled? Plus n and minus n are cancelled. Okay. Next, move to the next. From these two terms, what's a common factor? N into minus 1 to the power of n is a common factor. N into minus 1 to the power of n is common factor, divided by pi into a square plus n square into sine hyperbolic of a pi of e power of a pi minus a pi minus e power of a pi. In the next step, just now we know that what is sine hyperbolic x. Just now I had to explain. No, just few minutes before. Sine hyperbolic x is nothing but e power of x minus e power of minus x divided by 2. That implies e power of x minus e power of minus x is 2 sine hyperbolic x. 2 sine hyperbolic x. Okay. This implies e power of minus x minus of e power of x. Suppose you multiply it by minus sign, this become plus, this become minus, is nothing but minus 2 times of sine hyperbolic of x. Now this is in the form of this. Okay. Now this can also be written as n into minus 1 to the power of n divided by pi into a square plus n square into sine hyperbolic of a pi. Sine hyperbolic of a pi into, what is this actually? Minus 2 sine hyperbolic of a pi. You compare it. You compare from this to this. Okay. The next step, what happens? Sine hyperbolic a pi and sine hyperbolic a pi is cancelled. Now finally we get for Bn is What is Bn? Minus 2n minus 1 to the power of n divided by n square plus e square. Yeah, n square plus e square. Now observe carefully. I told after you writing for Bn is too far 1 to infinity or not, how can you know that? Pick the denominator quantity of Bn in terms of n. What is the denominator? N square plus e square equal to 0. N square is equal to minus a square. What is my n? Plus or minus a. A is a set of, suppose is a real number, maybe negative or positive. We get a what is the value for n is a imaginary. N is a imaginary value. But our summation n start from 1 to infinity is a set of positive integer. Even though give a positive value for a or negative value, we get a imaginary number. But none of the imaginary number is not involved in our summation 1 to infinity. Now this is a one of important thing. Even though we get n square plus a square, equate that we get n is equal to minus n square is equal to minus a square. Therefore n is equal to plus or minus ia. Plus or minus ia, n is a real number also. What we get is an imaginary number. But summation n, it's only have set of positive integers. Therefore this values does not belongs to in the range. Therefore we have to write true for n is equal to, this is true for n is equal to 1, 2, 3, etc. Next, based on that, we are going to construct the Fourier series. F of x is equal to, while writing a Fourier series, I'll keep minus 2 as a constant. You can't take this as outside because having a n also, 1 to infinity, n into minus 1 to the power of n divided by n square plus a square into sin nx is the required half range sine series for the given function over what's the interval? The interval is actually 0 to 2n. 0 to, not, sorry, 0 to pi, not 0 to 2n, 0 to, 0 to pi. N is pi. Yeah. This is a way to construct half-range Fourier sine series for the given function. The function is little bit different. Function is what actually? Sine hyperbolic ax divided by sine hyperbolic a pi. Sine hyperbolic a pi is a constant. Sine hyperbolic ax, how to do it means first we have to express in terms of in terms of what actually? Exponential function. Why we are going to express in terms of exponential means, once we express in terms of exponential, what we get actually? We get in the standard form of integration e power of ax into sine of bx plus r minus c. This formula we already derived where in PU level. With the help of that easily have to evaluate first term and also second term. Now I'll a little bit zoom out for student purpose. If you want to observe the entire problem in one screen, now this is a way I to solve the problem. I think you clear how to proceed for this, okay? In the next step, before moving to the next problem, again I'll show it after the zoom in of the given problem. This is my function. Don't confuse this function. Yeah, I'm trying to explaining, even though they are not giving the standard form, how to proceed, how to do smoothly, how to find out the solution for the half-range Fourier series for sine and cosine series. Now here, now sine hyperbolic case, instead of hyperbolic case, maybe we'll give cos. They are also first to express in terms of exponential e power of x plus e power of minus 6 by 2. Using that formula, express and simplify that. And then carefully apply your fundamental formula for integration e power of ax into cos of bx plus minus c. Simplify that. Now, even though we get some value, but that value is not in the range 1 to infinity. Therefore, this is true for n is equal to 1 to 3. Now, this is a way to do it, the problem. Okay. Now I move to the next problem. This also they given in the question paper, last year question paper. Today's second problem. Find the half range sine series of f of x equals sin x for 0 less than equal to x less than pi, cos x pi by 4, cos x for pi by 4 less than x less than equal to pi by 2. Now here they given a splitting function. The question is arise how to construct half range Fourier sine series or just sine series of the function. Now we already solved some few problems in the construction and general construction of Fourier series. Suppose the function is a splitting function. There what we did, we are once you splitting function means we are going to take overall interval. Here also we are going to take overall interval. The given is f of x is equal to sin x for 0 greater than equal to less than equal to x less than pi by 4 less than pi by 4. Okay, cos x pi by 4 less than x less than equal to pi by 2. What is our overall interval? 0 to pi by 2. In half range, what is our interval is 0 to L. Implies that what is my L is pi by 2. L is pi by 2. That implies what is my 1 by L? 1 by L is nothing but 2 by. Now n pi x by L. N pi x into what is 1 by L? 2 by pi. Pi pi cancel, what we get? 2nx. Now based on that we have to write the formula. Half range sine series of sine series for f of x over 0 comma pi by 2 is f of x is equal to summation n ranging from 1 to infinity bn sine of 2nx, where what is my bn formula? 2 by L. What is my L? Pi by 1 by L. 2 by L. 1 by L means 2 into 2 by pi. Yeah, 1 by L, 2 by pi. 0 to pi by 2 f of x sine of 2nx with respect to x. In the next step, we can't evaluate directly for 0 to pi by 2 because the given function is a splitting function. The given function is a splitting function, therefore 4 by pi of 0 to pi by 4. 0 to pi by 4. What's the function? Now we are going to split the integral 0 to pi by 2 at which point? Pi by 4, because they have a break at pi by 4. That's why we are going to give a break at which point? Pi by 4. Giving a break for the entire interval depends upon what type of splitting function they provide in the problem. 0 to pi by 4, what's a function? Sin x into sin 2nx with respect to x. Pi by 4 to pi by 2, what's a function they given? Cos x. Cos x into sine of 2nx with respect to x. Now, in the next step, I want to evaluate this by using the fundamental transformation formula because it's a product of two trigonometric function. Madam, it's a product of two function. Why don't you go for UV rule or Bernoulli's rule? We can't go for Bernoulli's UV rule because product of any one of the function is not equal to 0 after the few derivatives. Suppose you apply UV rule or Bernoulli's rule, the terms goes up to infinity in both first integral and also second integral. Why? Because none of the function, product of none of the function, either may be first term or maybe second term, is not equal to 0 after the few derivatives. Therefore, what you know that your UV rule, you can't go for that. Suppose you apply that, we get infinite number of terms. Once we get infinite number of terms, you can't we can't find out compact form or what is my definite value of Bn. It goes infinite. How to write in the summation Bn value? It's not, it's very tedious, it's not possible. Therefore, now using transformation formula, we are going to convert these two, product of these two trigonometric function must be sum or difference of two trigonometric function by using transformation formula. For first integral, I required sin A, sin B. What is sin A, sin B is nothing but 2 sin A, sin B is nothing but cos of A minus B, cos of A minus B minus cos of A plus B. Okay. Here, what is my A? A is x, B is 2nx. What is A plus B? Is nothing but 1 plus 2n into x. What is my A minus B? Is nothing but 1 minus 2n into x. This is for first integral. Similarly, for second integral is in the form of 2 cos of cos A sin B. What is 2 cos A sin B? Sin of A plus B minus sin of A minus B. What is my A? Is here x, B is also 2nx. We get same thing. A plus B is same, 1 plus 2n into x, and also A minus B also same. 1 minus 2n into x. This way I have to simplify. This is for the second integral. Now, anyway, here have 4. Keep 1 at 2. 4 can be written as 2 into 2. Write 1, 2 here. I'll take another 2 inside the integral. 2 by pi. Okay. Integration of 0 to pi by 4. Okay, fine. Now, what we get actually? So, 2 sin A sin B is nothing but cos of A minus B. A minus B is what? Cos of 1 minus 2n into x minus cos of A plus B, 1 plus 2n into x with respect to x. I move to the second integral. Again, I have to multiply with first integral and also second integral by 2. I already taken 2 inside the bracket. Pi by 4 to pi by 2. 2 cos A sin B is nothing but sin of A plus B means 1 plus 2n into x minus sin of A minus B, 1 minus 2n into x with respect to x. Okay. In the next step, I have to integrate. Integration, you know how to integrate cos and sin. We have to integrate here. While doing integration, I'll keep 2 by pi is a constant. Integration of cos. What is integration of cos? Sin. Okay. Sin of 1 minus 2n into x This is actually sine. Okay. Suppose you are confused, better I to erase it for this and then I to write once again sine of this divided by divided sine of 1 minus no need I to write here bracket only x divided by quotient of x 1 minus 2n minus of again integration of cos is sine of 1 plus 2n divide into x divided by quotient of x is 1 plus 2n. What's the limit? 0 to pi by 4. Okay. In the next step, similarly I move to the second integral plus now while doing integration of whatever sine, what is integration of sine? Minus cos of 1 plus 2n into x divided by quotient of x. What's quotient of x? 1 plus 2n minus, again I to integrate sine. Integration of sine is minus cos, we get minus, already have one minus sign here. For minus into minus plus cos of 1 minus 2n into x divided 1 minus 2n into x divided by quotient of x is 1 minus 2n. What's the limit? Pi by 4 to pi by 2. Okay, fine. Close the bracket. In the next step, before going to apply the limit, first we have to why don't to verify what happened sine and cos function corresponding the limits. Okay. Now sine of, then easy for the simplification. Sine of 1 minus 2n into, this is the first term I am talking about, into pi by 4. It's nothing but sine of pi by 4 minus 2 cancel with 4, what we get? N pi by 2. Sine of a minus b is nothing but, you know that sine a cos b minus cos a sine b. What is a here? Here this is my a, this is a, this is my b. Okay. A is pi by 4. Either sine pi by either, now no need I to write sine a. Yeah, if you, I'll write one. Similar, no need I to write because you know what is sine of a minus b. Sine a cos b minus cos a sine b. A is pi by 4. Either sine of pi by 4 or cos of pi by 4. What's the value is common? 1 by root 2. I'll keep 1 by root 2 outside. I'll write cos b. Cos b means what? Cos of n pi by 2 minus sine b. What is sine b? Sine of n pi by 2. I think it's clear. Just apply sine of a minus b. Once you apply sine of a minus b, sine of pi by 4, cos of pi by 4 is 1 by root 2. I taken common factor. That's all. Similarly, sine of 1 plus 2n into pi by 4 is nothing but sine of pi by 4 minus plus what actually n pi by 2 cancel with 4. Sine of a plus b. Same thing we get middle sign must be positive. 1 by root 2 into cos of n pi by 2 plus sine of n pi by 2. Similarly, I have to verify for cos. Cos of 1 minus 2n into pi by 4 is nothing but cos of pi by 4 minus n pi by 2. Cos of a minus b. What is cos of a minus b is nothing but cos a cos b plus sin a. So, cos a cos b plus sin a sin b. Cos a cos b plus sin a sin b. Cos a pi by 4. Sin a pi by 4. What's a common factor? 1 by root 2. What we get? Cos of n pi by 2 plus sin of n pi by 2. While move to cos of 1 plus 2n into pi by 4 is nothing but cos of pi by 4 plus n pi by 2. 2 cancel with 4. Again cos of a plus b. What is cos of a plus b? Is cos a cos b minus sin a sin b. Cos a cos sin a is 1 by root 2 because pi by 4, a is pi by 4 root 2. The middle sign compared to the previous step, we get minus. That's all. Yeah. Now we are going to this show and also, yeah, sin 0. What is my sin 0? 0. What is my cos 0? Cos 0 is say 1. And also you know that apply the pi by 2 and also I have to find out pi by 2 also. Pi by 2 for cos, not for the sin because here I am pi by 4 to pi by 2. Okay. Therefore, I want cos of another value 1 plus 2n into pi by 2. What we get? Cos of pi by 2, 2 to cancel in pi. What is the value of cos of pi by 2 plus theta? What is cos of pi by 2 plus theta? Now observe carefully here. Here we have what is the value? Cos of 1 plus 2n. Yeah, cos of 1 plus 2n into pi by 2. Once you multiply that pi by 2, what we get? Pi by 2, 2 to cancel in pi. What is cos of pi plus theta? Is minus cos theta. Minus cos, sorry, cos to sin. Sorry, 1 minute. I did mistake here. Just a minute. Okay. Yeah, observe carefully for this. Cos of pi by 2 plus theta. Cos of pi by 2 plus theta is nothing but you already know that cos of pi by 2 plus theta is nothing but if you want to, you know everyone how to write cos of pi by 2 plus theta and sin of pi by 2 plus theta. Now you apply that, what we get? Cos in pi, sorry, cos to sin. Now cos to sin. Now cos of a plus b. If it's the easiest way to verify, cos of a plus b. What is cos of a plus b? Cos a cos b sin a sin b. Now here, see, cos of pi by 2 plus theta is what? Minus sin theta. What is theta is? Minus sin n pi. What is sin n pi value? 0. This is the one way, or you know cos of pi by 2 plus theta is minus cos, pi by 2 is cos to sin, minus sin of, what's the value? N pi. What is sin of n pi is 0. Similarly, cos of 1 minus 2n into pi by 2 is nothing but cos of pi by 2 minus 2 to cancel n pi. Now here cos of pi by 2 minus theta is sin theta. What is theta? N pi, sin n pi. What is sin n pi is 0. Yeah, this is a way to do it. In the next, this shows that pi by 2 value for cos must be 0 in both the cases. Carefully I have to apply the upper and lower limit for this. Now 2 by pi of 1 by 1 minus 2n is a constant. Keep it outside. Apply the upper limit. What's upper limit? Sin of 1 minus 2n into pi by 4. Yeah, what is that? 1 by root 2 into cos of n pi by 2 minus sin of n pi by 2. You can't cancel any sin or cos comfortably because in none of the function is not equal to 0 for both upper and lower limit. At least it's not equal to 0, maybe upper limit, maybe a lower limit. Suppose it's 0 for both upper and lower limit, we are neglect that term. Okay. Minus lower limit. What is my lower limit here? 0. What is sin 0 is 0. Okay. And then move to the next term. While writing the next term, 1 by minus 1 by 1 plus 2n is a constant. Keep it outside. Apply pi by 4. 1 plus 2n into pi by 4 is nothing but 1 by root 2 into cos of n pi by 2 plus sin of n pi by 2. Okay. This is for 0 to pi by 4. For both term, move to the pi by 4 to pi by 2. Yeah. Now, while writing the third term, minus plus into minus is minus 1 by 1 minus 2n. It's a constant. Apply the upper limit. What is upper limit? Pi by 2. Cos of 1 plus 2n into pi by 2. What we get? 0. Minus lower limit. What is my lower limit? Is pi by 4. Cos of 1 plus 2n into pi by 4. This is what we get actually. 1. 1 by root 2 of, yeah, this is a thing I want to write. Third step this, cos of n pi by 2. Yes. Now this is cos of 1 plus 2n into x. Therefore, we have to write this one, not for that. Cos of a plus b. It's nothing but cos a cos b minus sin a sin b. Cos of n pi by 2 minus sin of n pi by 2. Yeah, close the bracket. Now here plus 1 by 1 minus 2n into upper limit. What is my upper limit? Upper limit is pi by 2. What is cos of 1 minus 2n into pi by 2 is 0. 0 minus the lower limit. Lower limit is pi by 4. Cos of 1 minus 2n into pi by 4. Lower limit is pi by 4. This we have to write. 1 by root 2 into cos of n pi by 2. Yes. Yeah, observe carefully for this. Now what we are going to write? Cos of 1 minus. This is plus. N pi by 2. Now observe carefully. This is a value for, so what actually? Sine, what about sine of, yeah, if you know, I have to verify before moving to the next. Sine of 1 minus 2n into pi by 4. What is sine of 2n minus 1 into pi by 4? This is something, yeah. Minus sine 0 is 0. Minus 1 by 1 plus no, 2n as a constant. Apply the upper limit. What's the upper limit is pi by 4. Cos of sine of 1 plus 2n into pi by 4 is, this is a thing. Yeah, correct. And next, keep the constant outside, apply pi by 2. Once you apply pi by 2 for 1 plus 2n or 1 minus 2n is 0. 0 minus 1 plus 2n. What is 1 plus 2n? Cos of 1 plus 2n into pi by 4 is this. Yeah, we are writing that. And next, uh, plus 1 by 1 minus 2n. Upper limit is what actually? 0. Upper limit is 0. Why? Because cos of 1 minus 2n into pi by 2 is 0. Minus 1 cos of 1 minus 2n into pi by 4. 1 minus 2n into pi by 4. This is a value. We have to substitute. Yeah, we substituted correctly. Yeah. This is 1 plus 2n. Yeah. This is 1 minus 2n. Yeah. Now this is correct. What I written here. Substitution is correct. Yeah. Simplify further. Now 2 by pi. Collect the term, those terms having 1 by 1 minus 2n. 1 by 1 minus 2n into 1 by root 2 into cos of n pi by 2, like that. First you observe carefully, you collect the term 1 by 1 minus 2n, and also from these two terms, what's a common factor? The common factors, observe, this is minus into minus plus. Please observe carefully, minus into minus plus. 1 by 1 minus 2n into 1 by root 2 cos of n pi by 2 minus sin of, both are must be same. We get 2 times of, and to add these two, what are things we are going to add? This one and this one we are going to add it. Once you add, what we get? 2 times of, because minus into minus plus we get same term 1 by root 2 into cos of n pi by 2 minus sin of n pi by 2. Okay. Next, observe carefully. Plus into minus is, yeah. Here, no, I did here mistake. I'll keep this is 1 by 1 plus 2n, correct? Yeah. Observe carefully. That's why this is each steps are very, very important. Well, suppose you did anywhere mistake, definitely you don't get it correct answer. Yeah, just a minute. I'm going to remove this. Yeah. Now here, observe carefully what I did. If you want, suppose you are confused now, see. This is 1 by 1 plus 2n. This is 1 by 1 minus 2n. Yeah, this is 1 by 1 plus 2n. No, we can't take what is 1 by 1 plus 2n like that. Common. Both are different. If you want to take these two, 1 by 1 plus 2n, you simplify that minus into minus plus. Then that's a thing. Otherwise, now first you correct 1 by 1 minus 2n. Okay, fine. 1 by 1 minus 2n. I'm going to correct. 1 by root 2 is there. Here also 1 by root 2 is there. I'm going to take 1 by root 2. Yeah. I'm going to take these two terms. From these two terms, 1 by root 2 of 1 by 1 minus 2n is common. What's the remaining here? For first term, cos of n pi by 2 minus sin of n pi by 2. Okay. For the now I to better I to write for this. Yeah, just a minute. I use some different bracket. This is one bracket. This is a first term. Keep the bracket for small bracket. Plus into minus is minus cos of n pi by 2 plus sin of n pi by 2. Okay, fine. The next step, collect the term, those term having 1 plus 2n. Yeah, 1 plus 2n. Observe carefully. The terms having 1 plus 2n is this term and this term. Okay. Now I have to take minus into minus. This is plus. Okay. This is minus. Only I'm going to take the common factor is plus 1 by 1 plus 2n 1 plus 2n into 1 by root. Yeah, better I to take some different notation. Observe the cross term. You take common factor is 1 by root 2 into 1 by 1 plus 2n. It's a common. Write the remaining term. What's the remaining? Minus of cos of n pi by 2 plus sin of n pi by 2. Okay. Now this is minus into minus. What happened? Plus cos of n pi by 2 minus sin of n pi by 2. Please observe carefully. Must and should have to do very carefully for this. Minus into minus plus. Okay. Minus into minus plus. Correct. Minus into minus plus. This is 1 plus 2n. This is minus into minus. This is minus. Okay. Now I have to simplify further very carefully. I'm doing little bit slow because suppose you are not done properly. This is given in the question paper. We have to do practice, then only easy to do it quickly. Okay. Now once you remove this bracket, cos n pi by 2, observe cos n pi by 2 minus cos n pi by 2 is cancelled. Minus sin n pi by 2 minus sin n pi by 2. What we get? Minus 2 sin n pi by 2. 1. And next, plus 1 by 1 plus 2n into 1 by root 2 of. Now I have to simplify this. Minus cos n pi by 2 minus cos n pi by 2 is cancelled. What's the remaining? minus sin n pi by 2 minus sin pi by multiplied by minus n minus and plus cancel minus minus we have to add. What we get? Minus 2 sin of n pi by 2. Okay. Now again we are going to take common factor from these two terms. Yes, 1 by minus 2 by root 2 minus 2 by root 2 sin n pi by 2 is a common. 2 by pi into 1 by root 2 into minus 2 sin n pi by 2 sin n pi by 2 is a common, because observe this is our common thing. What's the remaining now? Remaining is 1 by 1 minus 2n plus 1 by 1 plus 2n. Yeah. Now I'm going to explain separately 1 by 1 plus 2n and also 1 by 1 minus 2n. We take LCM and simplify. 1 plus 2n into 1 minus 2n. What we get? 1 minus 2n plus 1 minus plus 2n. What we get? 2 times. Therefore, simplify that. What we get? 2 times. Already 2 into 2, 4 by pi into root 2 sin of n pi by 2 of, this is nothing but 2 divided by, yeah, we have minus sign. Plus into minus is my 2 into 2, 4 minus. 1 minus 2n into 1 plus 2n. Yeah. In the next step, I take this negative sign in the denominator. Now I'm going to take this negative sign. I'm going to take this negative sign in the denominator. This 1 minus 2n can be written as 2n minus 1. In the next step, 4 2s are 8. 8 by pi root 2 sin of n pi by 2. If you want to write here itself, what we get? 2n minus 1 into 2n plus 1. I have taken minus n in the denominator. This is my bn. This is my bn. Now I want to know that whether this bn is true for all values of n. You pick the denominator factors. After once we get bn, you pick the denominator factor. What is my bn factor? What is a denominator bn factor is 2n minus 1 is one factor equal to 0. Another one is 2n plus 1 equal to 0. From this, what is n? Half. From this, what is my n? Minus half. But our summation is start from 1 to infinity. This shows that n is equal to half is not included. N is equal to minus half also not included. Our summation start from 1 to infinity. Therefore, confidently write this is true for n is equal to 1, 2, 3, etc. But the next is true. Either maybe get 0 or non-zero value, but you don't get it infinite value. Where will get infinite value? N is equal to minus half, n is equal to half. Both the values not included in our summation. Summation start from 1 to infinity. Now we are going to construct the Fourier series. What is my Fourier series? F of x is equal to 8 by pi root 2 is a constant. Keep outside n ranging from 1 to infinity. Sin of n pi by 2 divided by 2n minus 1 into 2n plus 1, okay, into sin of what actually? The sin of 2nx. Now observe carefully, we already know that sin of n pi by 2 is two cases. 0 if n is even, plus or minus if n is odd. Therefore, not necessary to take even cases here, because sin n pi by 2 0 means entire product must be 0. If we want to simplify further, pi by root 2, I have right? This is nothing but n ranging only we are going to take odd values 1, 2, 3, etc. to infinity because sin n pi by 2 0 even product must be a 0 means entire term must be 0. Sine of n pi by 2 divided by 2n minus 1 into 2n plus 1 into what actually sine of 2nx is the required half range Fourier sine series. Is the required half range sine series for the given function over what's the interval 0 to pi 0 to pi by 2 0 to pi by 0 to pi by 4 pi by 4 to pi by 2 means what's our entire range is 0 to pi by 2. Now this is a way to construct. I know this is a little bit tedious, we can't help, they've given already in the question paper, therefore I'm discussing in the class. Carefully I have to do it that now while doing simplification you must and should have to take care, then easy to understand that then how we have to simplify. Now this is this is actually what we are going to do here. Suppose I'm going to zoom out, we can't show it entire the problem very comfortable form. What I'm going to do here, I'm going to show it half of the problem first in one screen. Okay, this is my problem, start from that. Okay, yeah, this is a one set. Yeah, and next move to the second slot for this. Okay, yeah, observe carefully. This is a way I had to solve without doing confusion. Please try to understand what I did in this problem. Before I'm going to wind up, I'm going to brush up within a few seconds. I'm going to wind up today class. Now here, once you apply, now carefully apply what is your transformation formula. Better you write the general formula and then you replace A and B. After that, you integrate carefully. Once you integrate, you know that once you integrate, sine becomes cos, cos becomes sine. And then before going to apply the limit directly, first you find out what happened, the limit value. And then we have to proceed. I think you are clear for this, how I done. I taken much time to explain for this, not necessary to explain 1 second for that. And then finally, if you want, leave it this itself, but you know that what is sin in pi by 2. Suppose instead of taking 1 to infinity, you have to take only odd cases. This is a way to solve the problem. This is one of your last year final video question paper. Thank you very much for listening for talk what I explained, how to construct half-range Fourier sine and cosine series. I will come back again few more problems based on half-range Fourier sine and cosine series. I'm going to take different problem. The rest of the problem, please refer to my notes. Then easy to understand everything I written in my notes, cos of minus theta, sine of minus theta. Okay. Bye. See you and take care. I will come back again in the next class some more.